Hi everyone, welcome to this lesson on merge sort. In this video, we will break down how this sorting algorithm works step by step. By the end, you will understand how merge sort efficiently sorts an array using recursion and divide and conquer approach. So let's get started. First, what is merge sort? Merge sort is a powerful and efficient sorting algorithm. It works by dividing an array into smaller parts and sorting them, then merging them back in correct order. The key idea here is recursion and breaking down a bigger problem into smaller, manageable ones. The time complexity remains order of n log n, making it efficient for larger data sets. Merge sort works in three steps. First, we divide array into halves until we get single element subarray. Then we sort and merge the smaller array in order. The merging step ensures the final array is sorted. Let's see this process in action. Assume we have this unsorted array. Our goal is to sort this array using merge sort algorithm. Remember, merge sort follows divide and conquer approach. First, we will divide this array into smaller parts and sort them individually. Then we merge them back in a sorted order. We keep splitting each half until we are left with single element subarray. These individual elements are considered sorted because a single element is always in a order by itself. Now begin the merging phase. For example, we take 8 and 4. Since 4 is smaller than 8, we merge them as a 4, 8. Similarly, 3 and 7 become 3, 7. 6 and 5 become 5, 6. And 2 and 1 become 1, 2. Now next, we take this sorted pair and merge them even further. 4, 8 and 3, 7 are merged in, in a sorted order. Here we can see it's 3, 4, 7, 8. And similarly, 5, 6 and 1, 2 are merged into 1, 2 and 5, 6. Each step ensures the new array remains sorted. Now final merge. Finally, we merge these two halves together. We compare element by one by one, and merge them in sorted order, resulting in a final and sorted array. Now let's see the merge sort implementation in Python. So we start with the merge sort function, which is a main function that handles sorting process. Now, if my length of my array is less than 1, which is my base case, if the list has 0 or 1 element, it's already sorted, so we just return as it is. Then we calculate the midpoint of array, gives the left half of array and the right half of array to merge sort, and this process continues until we break the array into single element lists. Once we have the sorted halves, we call merge function to combine them back in single sorted array. The merge function will compare the elements of both halves and combine them in order. Let's see the merge function. So we start with an empty sorted array to store the sorted elements. I and j are the pointer to the current element of left and right halves. Now we compare the elements of each half. If left is smaller than right, then we add the left element to the sorted array and move the left pointer forward. Otherwise, right element is added and move the j pointer is moved forward. Once one half is fully processed, we extend to add the remaining element from the other half. This works because the remaining elements are already sorted. And finally, we return the sorted array which contain the elements from both halves, sorted in correct order. So let's discuss the time and space complexity. Merge sort has a consistent and log n complexity in all cases, making it much better than bubble sort and insertion sort for larger datasets. However, it requires extra space, making it less efficient than quick sort in terms of space. Pros and cons of merge sort. Merge sort has several advantages. It guarantees order of n log n time, which is stable and work for large datasets. In cons, it requires extra space, which can be a downside for memory constrained environment, and it is not suited for smaller datasets.